Hi everyone, welcome to Learn with Chaitra. In previous class, we are discussed about the concept solution. It is in 12th standard and it is very important. But I revised in yesterday class, I revised all the concepts are present in the solutions like what is solution and about solvent, about the examples, and what is solute, what is concentration of the solution and the molarity and the binary solution a concentration. In concentration, we are discussed about the qualitatively and the quantitatively. In quantitatively, in on quantitatively, mass by volume percentage and the mole fraction. And then we are also solve one problems on the mole fraction. And today's class, let me solve one problem. Before that, I will give you one demo on the solution. So look at here. It is a solvent. Here the solvent is water. And it is the salt. Here salt is the solute. When the solvent is react with the solute, it gives the solution. Overall, we call it as salt solution. If in case I take in the sugar, if the sugar is reacts with a solvent, it gives sugar solution. Like that. Here the water is the solvent. The solvent is larger amount in a solution, but the solute, here I taken as salt as a solute. The substance in lesser amount. The substance is lesser amount is the solute. Here I taken as salt. Salt as a solute. You can take the sugar, other materials, other substances as a solute instead of salt. If I add the salt on more quantity on a solvent, but it dilutes. If I add the more quantity of the solutes on the solvent, is the concentration is increases. What is the concentration of the solution? The concentration of the solution is refers to the amount of the solutes dissolved in a substance present in a given volume of a solvent. Here the solvent is the liquid in state with a solution. Essentially, how much of the substance is dissolved in a specific amount of a liquid, often measured in terms like molarity. Adding more solute increases the concentration, while adding more solvent dilutes the solution. Okay, let's come. We can solve the problems on the molality and the molarity. Okay, the question is to calculate the molarity of the 25 gram of the ethanoic acid CH3COH in 75 gram of benzene. First, we have to calculate the molar mass of C2H4O2. The molar mass of C2H4O2 equals to the number of carbons are present 2. So the mass number of the carbon is 12. So 12 into 2 plus hydrogen 1 into 4 plus oxygen 16 into 2. Then the final answer is 60 gram per mole. 60 gram per mole. The moles of C2H4 and O2 equals to how many grams they are given? 25 gram. 25 gram divided by the molar mass of the ethanoic acid is 60 gram per mole equals to 0.0417 mole. This is the moles of the C2H4 ethanoic acid. Then the mass of the benzene in kg. Mass of 75 gram. How many grams they are given? Benzene 75 gram. For 1 gram equals to 1000. So 75 gram divided by 1000 gram per kg equals to 75 into 10 power minus 3 kg. And the final answer is the given formula, the molarity equals the moles of the solute divided by mass of the solvent in kg. So of C2H4O2 divided by the mass of the solvent in kg. The mass of solvent here the solvent is benzene. So the kg of benzene equals to here 0.0417 mole into 1000 gram per kg. The kg of the benzene, how many kg they are given? 75 kg. Sorry, 75 gram. And the final answer is 0.0 mole per kg. Is the final answer of the molarity. Molarity. Here the given problem on the molarity. Calculate the molarity of a solution containing the 5 gram of NaOH in a 450 ml solution. The molarity formula, molarity equals the moles of the solute divided by moles of the solution in liter. Here they are given the moles of NaOH. The moles of NaOH here they are given. So here they are given 5 gram of NaOH, right? So 5 gram divided by how much numbers of moles of present of NaOH in NaOH? The moles of NaOH, sodium 23 plus oxygen 16 plus hydrogen 1. Total number is 40. So 40 gram per mole equals the moles of NaOH equals to 0.125 mole. For 50 ml of solution, for 1000 ml it becomes 450 ml divided by 1000 ml. Per liter. Volume of the solution in liter. So it becomes finally the moles of the solutes are present 0.125 divided by volume of a solution in liter equals to 450 ml. Here this denominator is goes to numerator. So 1000 ml per liter. Ml per liter. 278 m. M means molarity. We can write this as 0.278 mole per liter. Mole per liter is equals to m, molarity. Here also we can write it as 0.278. Next concept is solubility. The solubility is the ability of a solid, liquid, and the gaseous chemical substance to dissolve in a solvent. And the solid, liquid, and the gaseous chemical substance is referred to as the solute. It is dissolved in a solvent. Usually, the solvent is in a liquid form and form a solution. The solubility of a substance fundamentally depends on the solvent used as well as the temperature and the pressure. Okay, give you one example. Here the solute. Here the solute is it will. Here the solute we can take as a solid, liquid or gaseous chemical substances, and it is reacts with the solvent, then we get the solution. Here I taken as the solute as sugar. The sugar is reacts with a solvent. Here the solvent is the water. The water is reacts with the sugar. We get the sugar solution. Here the amount of the water is depends on its the solubility. Now the amount of water is present in the solution is depends on the solubility. The solvent is the water, and the temperature and the pressure is depends on the solubility. And the next concept is liquid. Here the solid is the solute and the liquid is the solvent. The solubility of a solid in a liquid is the maximum amount of solid that can dissolve in a specific amount of a liquid at a specific temperature. It's a physical property of the substance. I gave you already one example. The solid form. Solid form is a salt. The salt is a solid form. Here it will be taken as a solute. It reacts with the solvent as a water. It gives you the solution that can dissolve in a specific amount of a liquid at a specific temperature. How much amount of the water we are taken is depends on the solubility and the specific temperature and the physical property of the substance as well depends. The factors depends on the factor that affects the solubility, the temperature, the solute solvent interaction, and the nature of the solute and the solvent, and the pressure. The temperature. The first one is the temperature. The solubility usually increases with the temperature of the solids in a liquid water. This is because the higher temperature increases the kinetic energy of the solute molecule. The solute and the solvent interaction. The strong solute solvent interaction leads to greater solubility. The nature of the solute and the solvent. The polar solute dissolves in the polar solvents and the non-polar solute dissolves in non-polar solvents. And the next class I will explain the definition of the non-polar solutes, what are the non-polar solutes and the polar in the next class, I will explain about the polar solvents, non-polar solutes, and the non-polar solvents. Okay, and the pressure. The pressure doesn't usually affect the solubility of a solids in a liquids. Example, I gave you example. The substances that dissolves in water, sugar, and the common salt. An example. In a liquid at a given temperature and a pressure. It is affected by the pressure, it is affected by the pressure, temperature, and the nature of a gas and the liquid. The factor that affect the solubility. It is same as the solubility of a gas in it is same as the solubility of a solid in a liquid. It also has some the factors. The factor that affect the solubility is in a gas, solubility of a gas in a liquid is the pressure. First one is the pressure. The solubility of a gas in a liquid increases as the pressure of the gas increases. This is described by Henry's law. And the temperature. The solubility of a gas in a liquid decreases as the temperature also decreases. This is because the thermal energy of the heat overcomes the attractive forces between the gas and the solvent molecule. The nature of the gas and the liquid. The nature of the gas and the liquid, such as the intermolecular forces, also affect the solubility of the gas solubility. Application of gas solubility. Scuba tanks. The scuba tanks also one of the example. Scuba tanks contains a mixture of helium or oxygen, and the solubility of the helium in your blood is low. So the divers experience a fever gas bubbles in their bloodstream when they surface. Henry's law states that the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas above the liquid. Next one is the Henry's law. Henry's law states that the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas in a liquid. When the solubility of the gas in a liquid increases with an increase in that pressure at a given temperature, conversely, the solubility of a gas decreasing the pressure. As an increase in temperature decreases the solubility of a gas in a liquid, the solubility of gas is applied in a making of scuba tanks. The effect of the pressure. The Henry's law this is relates the solubility of a gas over a solution based on the factors of temperature, volume, and the pressure. The why your offering gets less physic weak. The greater the pressure, above the more gas is dissolved. So, and the Henry's laws find the several application in industry and some explain some biological phenomena. Notable among these are to increase the solubility of the CO2 in a soft drinks. Carbon dioxide is present in a soft drinks like soda water, Coca-Cola, and Pepsi. The bottle is sealed under high pressure. Scuba divers must cope with a high concentration of a dissolved gases while breathing air at a high pressure underwater. The increase in pressure increases the solubility of the atmospheric gases in the blood. When the divers come forward towards the surface, the pressure gradually decreases. This releases the dissolved gases and leads to the formation of the bubbles in the blood. This blocks capillaries and creates a medical condition known as bends, which are painful and dangerous to life. To avoid the bends as well as the toxic effects of high concentration of the nitrogen in the blood, the tanks used scuba dives are filled with air diluted with helium. The 11.7% of the helium and the 56.2% of the nitrogen and 32.1% of oxygen at high altitudes. The partial pressure of the oxygen is less than that of at the ground level. This leads to low concentration of the oxygen in the blood and tissues of people living at a high altitudes of the climbers. The low oxygen causes the climbers to become a weak and unable to think clearly, and the symptoms of the condition known as anoxia. So